Hello and welcome to this video on circular permutations and reflectivity. Today we're going to take a look to see what happens when we look at probabilities dealing with things with circles, circular arrangements. To start off, let's look at something we've seen before. Okay. In how many ways can 5 people sit in 5 chairs in a row? Okay. Order matters, so this is going to be a permutation problem. Now if they're in a row, let's go back here. If they're in a row, then that means we have 5 different slots in a row. And once a person sits in a chair, you have one less number of people to deal with. So we have 5, 4, 3, 2, and then one person's left for that last chair. So we essentially have 5 factorial, which gives us 20 times 3 is 60, 120. 120 ways. Now let's rephrase this question in a slightly different way. In how many ways can 5 people sit in 5 chairs in a circle? Not in a row, but in a circle. Meaning you have chair 1, chair 2, chair 3, chair 4, chair 5. Okay, they're in a circle. Well, the question is, which chair do you start in? Okay, let's say we start in this chair right here on the top. So there's 5 ways you can sit in that chair. And then 4 people left to sit in the second chair, 3 people to sit in the third chair, 2 in the fourth chair, and 1 in the last chair. So it still looks like 5 factorial, which is 120. However, we don't know exactly where the first chair you're sitting in is in a circle, because there's no definitive starting point. Okay, if there is a starting point, which by the way, and you'll see in a moment, is called a fixed point, it's a starting point, then it's just like you were in a row, just like that first problem, okay, in factorial. Okay, but if you start at the top chair, or start at the chair where the 4 is, or chair where the 3 is, there's 5 different possible places where you can start. Now, if you went around in the same direction, counterclockwise, or actually this way, clockwise, then you essentially had the same arrangement. But we have to count for those repeats, so I'm going to divide that by 5. Notice 5 factorial is 5 times 4 times 3 times 2 times 1, divided by 5. That turns into a 4 factorial problem, which, as you notice, is 1 less than what we started off with, 5 minus 1 factorial. 4 times 3 times 2 times 1 is going to be 24. So the answer to this problem is 24. Oh, and there's some words there. 24 ways. Alright, so this is introducing us to the concept of circular permutations. So let's look at a table that we can use to help set up a way to help figure out what kind of equation or what kind of way we're going to use to solve these problems. So fixed and not fixed is kind of what I just illustrated. If there's no fixed point in reference to where you're beginning in the circle, then it's going to be n minus 1 factorial. But, as you saw, if you're in relation to a particular chair in a circle, it is still going to be the same as before, n factorial. So fixed is going to be n factorial, not fixed is going to be n minus 1 factorial. Now the other concept that I want to look at in this lesson is reflectivity. Now when things are in a circle, there's a lot of times where there's something happening called reflectivity. Now a situation is considered reflective if there are 2 ways to view one arrangement. So reflective occurs when there's 2 ways to view an arrangement. Okay? That means you have a reflective situation. 2 perspectives, same arrangement, but look differently. And a common example of this is going to be a bracelet. Okay? If you look at a bracelet, if you have charms around a bracelet, if you have charm A, then charm B, C, and then D around in that order. If you were to flip the bracelet upside down, then they'd just be in the reverse order. But that's the exact same arrangement of charms, it just is reversed. So for reflective, what we're going to do is we're going to count for all the doubles by dividing by 2. So if you have a reflective situation that's not fixed, it's going to be the n minus 1 divided by 2. If you have a reflective situation that is fixed, it's going to be n factorial over 2. So reflective, divide by 2. Not reflective, don't divide by 2. Pause the video, write down anything you need to before going on to some practice problems. Okay, let's look at some practice problems. So the first one. So for each of these, we're going to be asking ourselves, is the situation a fixed circular permutation, or is it not fixed? And then we're going to ask ourselves, is it reflective or not? So first, if 5 people are seated at a round table, how many arrangements of people are possible? Round table, that tells you circular permutation. Okay, so you're asking, is it fixed or not fixed? And notice in this case, there's nothing that we're in relation to. We're not in relation to the door to the room, or to the window, or to a particular chair. So this is a situation that is not fixed. Okay, which means we're going to be dealing with n minus 1 factorial. Now the next question is it reflective? Things in a circle can be looked at from 2 perspectives, but sitting around a table, you can only one perspective that makes sense, and that is from kind of the top. You're not going to look at the arrangement of people from underneath the table. It just doesn't make sense. So this is not reflective, not reflective. So I'm not going to divide by 2. The question now becomes what is my n value? My n value is going to be 5 because we have 5 people. So what we're essentially doing is we're doing 5 minus 1 factorial to find the number of arrangements possible. So 4 factorial, and I believe we just calculated this, 4 times 3 times 2 times 1, which is 24 arrangements. Alright, let's look at number 2. In how many ways can 7 people sit at a round table relative to a particular chair? In this case, because it says relative to a particular chair, that's clearly indicating we're in relation to a fixed point around the circle, that chair in particular. So we're going to be dealing with n factorial. And again, we're around a table, and it only makes sense to look at it from one direction, one perspective, so it's going to be not reflective. I'm not dividing by 2. And how many ways can 7 people sit at the table? So our n value is going to be 7. So it's going to be essentially 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply that all out and you get 5,040 ways. Pause the video, write down anything you need to. Alright, moving on. Number 3, how many arrangements are there on a bracelet with 5 charms on it? And I indicated that there's no clasp. Clasp is that little, as you know, that little thing that kind of holds it together. Now, if there's no clasp, you might be asking yourself, well, how did they put the charms on the bracelet anyways? Well, that's irrelevant. Let's not worry about that. Okay, no clasp means there's no fixed point. So it's not fixed. So we're going to be dealing with n minus 1 factorial. And that kind of looks like a 1 or L or something, so I'm going to redo that. There we go. N minus 1 factorial. Now the question we're going to ask ourselves now is it reflective? And with bracelets, you can be sure that they're always going to be reflective. It'd be a pretty weird bracelet if you can't flip it upside down. Alright, so divided by 2, because it's reflective. And we have 5 charms, so our n value is going to be 5. So what we're doing is we're doing 5 minus 1 factorial divided by 2, which is essentially 4 factorial over 2, which is 4 times 3 times 2 times 1 divided by 2. Cancel the 2's, leaves you with 12 arrangements. Alright, one more problem. 12 beads are strung on a necklace. 3 of them are blue, 6 of them are red, and 3 of them are white. How many arrangements of beads are possible on the necklace? Okay, I didn't indicate if there's a clasp or not. So this is going to be another not fixed situation. It's not specific if there's a class, so if it's not specific, you can't assume that there is one. And this is also still reflective. So we're going to divide by 2. And our n value is going to be 12, because it's 12 beads. So essentially what we're looking at is 12 minus 1 factorial over 2. However, in this case, we have to add a few things, because notice we have some repeating beads, repeating colors. We have 3 blue, 6 red, and 3 white. So we're gonna do something very similar to what we did with the digits and the words. Right? We have in this case we have 11 factorial on the top because it isn't fixed, and we have the divide by 2. But we have to take into account the 3 beads that are blue as repeating, so we're going to divide by 3 factorial. And then 6 of them are red, so we're going to divide by 6 factorial. And 3 of them are white, so I'm going to divide by 3 factorial. Now just take a note, 3 plus 6 plus 3, that's 12, so it takes care of all the beads. Okay, sometimes you'll have to find the last number because I won't tell you how many are in that last, but this one's I give you all the numbers. Alright, so let's do this out. You can plug 11 factorial into your calculator, but you'll get a fairly large number. So let's simplify this by actually doing this out. Now notice that 6 factorial is the largest one in the denominator, so I'm going to do the top 11 factorial all the way up to 6 factorial. So I can cancel the 6 factorial. So 11 times 10 times 9 times 8 times 7 times 6 factorial. We'll finish it off. Divided by 2 times 3 times 2 times 1 times 6 factorial times 3 times 2 times 1. So I'm going to go ahead and cancel off the 6 factorial just to get that started. And be careful about the rest of them. Okay, I see maybe the 3 and the 3 make a 9, so I'm going to cancel with the 9. The 2 and the 2 and the 2 all make 8, so I'm going to cancel with the 8. 2 times 2 is 4, times 2 again is 8. And that takes care of everything. So I just have 11 times 10 times 7. Multiply all those out, you get 770 ways. Alright, pause the video and write down anything you need to. Alright, so as you saw, we had 2 central concepts in today's lesson, dealing with circular situations, circular permutations. Okay? If you have things in a circle in relation to a fixed point, it's just no different than what we did before. It's n factorial. If you have things in a circle with no fixed point, it's n minus 1 factorial. The other major concept was reflectivity. And if it was reflective, then you divide it by 0. Divide by 2. Divide by 2. I'm mixing up all these lessons. I'm doing so many things at once. Okay. Divide by 2. If it's not reflective, then you don't divide by 2. Okay. And as you saw, there are some situations where if you're dealing with beads on a necklace, you may have to divide by the repeating number of beads for each color. Okay, so this is a good summary for a lot of the things we've been doing. All right, thank you for watching, and tomorrow we'll be looking at some practice problems in class. Thanks. Bye.